Let us derive an expression for drift velocity. Drift velocity is denoted by a symbol called as v suffix d. To derive this, let us consider a conductor of length L and let its area cross section be some capital A. So A is area of cross section. Let us consider two ends called as end P and end Q, across which a potential difference is applied. Potential difference will create an electric field as shown in the figure. Let this system or conductor contain capital N number of free electrons. So it contains N, which is number of free electrons. We have learned in the free electronic model that the electrons will randomly move, which means before applying the electric field, the electrons will have its own initial velocity. Let us call it as u1, u2, etc. u1. So these are the electrons' initial velocities. Now we have learned that the electrons will move randomly, which means the average of all these values, if you look at the average of all the electrons initial velocity, this is equal to 0 because they move randomly. Now in presence of an applied electric field, electrons will start to move. So the force on any electron is given as, by definition, the force is given as Q into E, and since here Q is minus G, which is charge of electron, we can say the force on any electron is equal to minus of E into capital E. Minus sign indicates that the electron moves opposite to the applied field. As shown here, a given electron moves opposite to the applied electric field. Now this would mean the electrons will have an acceleration. So the acceleration of any electron, which is called as A, this A is given by force by m, where here m is mass of the electron. Therefore from here we can say A is equal to minus of E by m. So this is the acceleration. Now because of the acceleration, the electron's velocity will change. Let the velocities of the electron after some time be called as v1, v2, etc. So v1 is the velocity of the first electron after some time. So this is equal to u1 plus a into tau 1, where this tau 1 is called as relaxation time for the first electron. Similarly, v2, the velocity of the second electron, is equal to u2 plus a into tau 2, where again tau 2 would be the relaxation time for electron 2. Right, in the same way, we can say Vn, that is for the nth electron, Vn is equal to un plus a into tau n. Now we learned that the electron's velocity will be different, and if we find its average value, then what we get is the average of all these values, which is v1 plus v2 plus etc. vn. If we find its average value, this by definition is called as drift velocity. Now that is equal to if we put it back here, then V1 is U1 plus A into tau 1 plus, writing same thing everywhere, plus it is U1 plus A into tau 1 by N. That is equal to, they can rearrange the terms here, it is U1 plus U2 plus etc. Un by N, and here A is common, so it becomes tau 1 plus tau 2 plus etc. tau 1 by N, and we just now saw that this value is equal to 0 as given here. So it's given here that the average values of U would be 0. Therefore, this means that Vd is equal to A into, we'll call this as some tau. So it becomes A into tau, where this tau is called as average relaxation time. But we know what the value of A is. Capital A is equal to minus E capital E by M. Putting it back here, we get Vd as, it is equal to minus E tau by M. So this is the expression for drift velocity. Again, in terms of magnitude, Vd is equal to E tau by M. As seen here, this drift velocity depends on few factors. It depends on the electron charge, the applied electric field, because if the field is greater, electrons will start to move faster also. It depends on tau and also M. So this is the expression for drift velocity.